All right, so we're looking at 2.1 and it's long division. So we learn about this in elementary school and we're going to review long division just with regular numbers and then we're going to go into polynomial long division. So when we divide by something with long division, what we're dividing by 73, it goes on the outside of our long division bar, and then 91/25. So when we're looking at these, we're looking at just 73 and 91. Okay, we're ignoring the 25. So we're trying to think, how many times does 73 go into 91? And it is one time. So we write the 1 up here and then we multiply. 1 times 73 is 73 and we write it underneath and then subtract. So 91 minus 73 gives us 18. And then do you remember what's next? You drop down the next number, so 2. So now we're looking at how many times does 73 go into 182? We're only focused on that. So 73 times 2 is 146. But if we go 3 times, we're over, and we don't want to go over. So we're actually going to write a 2 up here. 73 times 2 is 146. So that we write down here, and then we subtract. So 182 minus 146 gives us 36. And then last one is we bring down the next number, which is a 5. So 73 goes into 365 how many times? That's what we're trying to figure out. And that's the number that goes on the top. So you can keep multiplying on these. 3, 4, 5. So 73, times 5 is 365. If we subtract that, we get 0. Well, this 0 is our remainder. And the 125 would be our quotient. And we just found out that 73 times 125 gives us what we started with, 91/25. So dividing is the opposite of multiplication. So remember, they go together. If two things multiply, one of them divides. Okay, so I'm going to do one more really quick. We have 5 divided by 17/23, and this will go faster because of the 5. So again, we're looking at how many times does 5, it's not just 1, that would be 0. So we have to go to the next number. How many times does 5 go into 17? If you know your times tables, it goes faster. That's on all of this stuff in Math 3. So 5 times 3 is 15. You subtract and get 2, and then you're going to bring down the next number, which is 2. How many times does 5 go into 22? 4. 4 times 5 is 20. Subtract. And then you bring down the next number, which is 3. So how many times does 5 go into 23? Also 4. And this time we have a remainder, which, remember, if we were to write our answer, it would be 344, and then we would put our remainder over what we're dividing, 3/5. That would be our answer. So when we have a remainder, we create fractions. Okay, so let's do one with polynomials. I wrote out the steps. They're kind of hard to follow. Just the steps. It helps to see examples with it. So I'm going to set it up. X minus 2 divided by x cubed plus x squared minus 7x plus 2. And step 1 says make sure the polynomial is written in descending order. If any terms are missing, you have to fill them in. So we have one that none are missing. Our exponents go 3, 2, 1, and then they're done. So ours are fine now, but we'll run into examples where you have to worry about that. Okay, divide the terms using the highest power. So I keep doing that. Remember on our last one, we were only looking at certain things. So I'm looking at x and x cubed. So how many times does x and x cubed have to be multiplied? Or how many times does it go into that? That's what we were doing up here. So when it says divide, it's x cubed over x is x squared. Another way to think about that is x times what gives me x cubed? Well, you have one, you need 2 more. So there's a couple ways to look at that. And then I'm going to multiply, just like what we did last time. Oops. All right, so I'm going to multiply both of these by x squared. So x times x squared is what we want. That's the goal, for those to be the same. And then we continue multiplying. So negative 2 times x squared is negative 2x squared. And then we subtract, just like what we did before. I'm going to erase those, get them out of the way. So we're going to subtract this. And the difference here is we have to subtract 2 terms. So remember in our last section, we're changing the signs. This subtracts, and then when you subtract a negative, it turns to a positive. So don't forget that. Okay, these are going to cancel out. That's the goal. That's what you want. And then 1x squared plus 2x squared is 3x squared. And you bring down the next term. Then we start over, just like we do with our other long division. I'm going to change colors this time. So now I'm focused here. 3x squared and x. And it's the same concept. Okay, what do we need to multiply x by to get 3x squared? So it helps to divide if you want. And then you're left with 3x. Or you can say x times what will give me 3x squared. So x times 3x. And that's our next term in our quotient. And then we do the same thing, we multiply. So we're going to times 3x by both of those. So 3x times x is 3x squared, which is the goal. That's what we want. And then 3x times negative 2 is negative 6x. I'm just erasing those so they're out of my way. And then we subtract both of these. So remember, we subtract, this changes to a minus, and then this changes to a plus. The goal is these always cancel. That's what we want. And then negative 7 plus 6 is negative 1 and x. And then we bring down our last term. Okay, so now we're focusing on this x and this x. So what do we need to add to our quotient? What times x gives you negative x? And if you're not sure, divide them. Negative 1x divided by x is just negative 1. So when you multiply that both times, you get negative 1x, and then negative times a negative is a positive. They're the same. But remember, we have to subtract. So when I subtract these, the signs change. This changes to a positive, and this changes to a negative. And so they both cancel out, giving us a remainder of 0. So this is our quotient. That's what we just found. So you're like, what does that even mean? So we just found if we take x minus 2 times our quotient, x squared plus 3x minus 1, we get this, x cubed plus x squared minus 7x plus 2. So remember, we're finding the parts of multiplication that are missing.